are going to start by graphing sine and cosine functions. So just like we graph linear functions, y equals x, it's a line. Quadratic, y equals x squared, is a parabola. And we have many functions. Well, sine is also a function, and we are going to learn how to graph it. And we are going to do this by hand at the moment. So let's first look at this table. We're going to fill in the table by using our formula chart. So sine of x, so sine of 0 is what we would be looking for. So we're using our chart. So remember, sine is y, cosine's x. Remember the Barney song? So if sine is y, we are going to look at our formula chart and figure out what 0 at 0, so right here. Sine is y, so sine is 0. So sine of 0 is 0. Sine of pi over 2. So now we go on our chart, the unit circle, go to pi over 2 and figure out what y is. So pi over 2 is the 90-degree angle, so sine is y. So y is 1. Okay, now look at pi. So sine of pi, so go over to the 180 degree. What is the y value there? 0. And then 3 pi over 2, go to your unit circle, go to 3 pi over 2. What's the y value there? -1. And then 2 pi, well, that's just back to 0, right? Because it's 360. So it would be 0 also. So we have these points. And those are called our key points. So we are going to write those down as ordered pairs. So 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. This completes one cycle of the sine function. So we are going to draw what this looks like. So we're only in quadrant 1 and 2. So I'm just going to draw quadrant 1 and 2 like that. The x values start at 0 and they go to 2 pi. So I'm not going to put 0, but I'll put pi over 2. Then pi, then 3 pi over 2, and then 2 pi. Those are equal distance apart. And then our y values are from 0 up to 1 and down to -1. So we'll plot our points. So 0, 0 is a point, so that's at our origin. And then we have pi over 2, 1. Then we have pi 0. 3 pi over 2, -1. And 2 pi 0. And we're going to connect it with a smooth curve. So, like this. So that is our sine function, y equals sine of x. It's basically our parent function for the sine function. If we were to continue making more and more points, then we would continue to follow this same pattern. So it's cyclical. Yeah. Where do you see sine waves at?
Sound.
In sound. So it continues to go up and down, up and down, up and down. And see how it stays centered on the x-axis? And so the cosine's a little different. But yeah, it follows that same pattern. And so there's different parts of this. So I'm going to use a different color to represent those. So we have the period is from here where we go through one cycle. This is called a period. So this one, the period goes from 0 to 2 pi. So it's a period of 2 pi. Period. So 2 pi. And then the amplitude, you recognize that in sound too, right? It goes from the midline up. So basically it measures how far from the midline that you run. So I'm going to do a dotted line right here. This is called the amplitude. And we can abbreviate it like amp. So you can measure it going from midline up or from midline down below. So it's basically half the distance from the min and the max. And so for this, the amplitude, so I'm going to call it A. A equals 1 because it goes from 0 up to 1. So it's measuring the y distance. So this continues to go up and down, up and down. All right, so let's go to the cosine. I'm going to change back my color. So cosine of x, so when we do cosine of theta, whatever theta is, sine is y. I should have wrote that over here. Sine of theta is y. Cosine is x. So in order to do our table of values, we're going to do cosine of 0. So the x value on 0. So we'll look back over here. So at 0, x value is 1. Pi over 2. So if we do cosine pi over 2, so look at your unit circle. Pi over 2. I'm going to click it. It's x, right? The x value is 0. There we go. Let's go back. And then at pi, so that's over at the 180, the x value is -1. Then at the 270, the 3 pi over 2, that is 0. And at 2 pi, we're back to 0 and 2 pi are the same, so it's 1. All right, so this is also just in quadrant 1 and 4. So we're going to draw that. And the x values are the same, so pi over 2, pi, 3 pi over 2, and 2 pi. And then the y values range from -1 to 1. So we'll plot those to make our cosine function. So it is 0, 1. Pi over 2, 0. Pi, -1. 3 pi over 2, 0. And 2 pi, 1. So we're going to follow that same pattern of connecting it with a smooth graph. Smooth line. And put arrows on the ends. So sine went through the origin. Cosine didn't. It started at the y-intercept of 1. Okay, so let's represent the period and amplitude. So period would be from the very beginning to the last of one cycle. So here the period is 2 pi. And the amplitude is the distance from the midline up to the top or down to the bottom. So I'm going to just do like this. Amplitude is going to be represented with A, and it is 1. And we need to write down the key points like we did on sine. So 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and 2 pi 1. So those are the key points. So we have 1, 2, 3, 4, 5 key points that make up one cycle. And that cycle continues and follows that, squiggly up and down, up and down, up and down with a smooth graph. All right, so we have already talked about amplitude. So it says the amplitude of y equals a sine x and y equals a cosine x represents half the distance between the minimum or the maximum and the minimum values of the function. It's given by amplitude equal absolute value of a. So it's a distance. So if your amplitude or your a value is negative, you take the absolute value. So it's a positive amplitude because it's distance. So it is the height of the curve from midline up, if you want to write it in a different way. Height of curve, midline to max / min. And it's always going to be positive because we find it using the formula, which is absolute value of A. A is the number in front of your cosine or sine function. Okay, find the amplitude of each. So here we have A is negative 4. So the amplitude, absolute value of A, is positive 4. Two, we have 2/3 sine x. The amplitude is going to be 2/3. Number 3, A is 5. So the amplitude is 5. And then for A is negative 7, but the amplitude is positive because you take the absolute value, so it is 7. Okay, so that's whenever there's a value in front of cosine or sine. If there's nothing in front, it's automatic 1. So we use A equals 1 there. A period is a horizontal distance from the beginning and end of one cycle. So B is how we are going to find it. B is after the sine or cosine. So it's A sine BX or A cosine BX. And it is given by period equals 2 pi over B. So you look at your function to find your B, then you do 2 pi divided by. For our parent function, for sine and cosine, the period is 2 pi. All right, so number 1, we have, this is B, this is A. So if you just want to kind of identify them. So to find your period, we're going to do 2 pi over 2. So our period is pi. The next one, 2 pi over, well, this is x over 2. That really means 1/2 x. So 2 pi over 1/2. So when we do that, it's really 2 pi times 2 over 1. So our period is 4 pi. That's the distance of one cycle. Okay, number 3, we have B is 3. So it's 2 pi, to find your period, 2 pi over 3. Nothing we can do to simplify that, so we leave it. And then our last one, 2 pi over 2 over 5. That really means, when we simplify it, 2 pi times 5 over 2. So the 2's are able to simplify out, leaving us with 5 pi. Okay, transforming. So the transformations of sine and cosine, similar to when we transform quadratics, exponential, absolute value, all of those functions. Each of these values that are in those spots of A, B, C, and D represent something and how it's transformed. So we're going to see that. So A is our amplitude, right? So that's what, does the distance from midline up. The C value is the one that transforms it horizontally, but it is the one that does the opposite. See how it has minus C in the formula? So it's going to do opposite of what you think it would do. So I call it, whenever I teach us to Algebra 1, when we talk about transforming linear and quadratic, it's called our crazy X, and it does the opposite of what you think it will do. And then the D transforms it by moving it up and down vertically. Okay, and then it also has a little special note here. If C equals 0, then Y equals A sine B of X plus D. So there wouldn't be a plus or minus C value. So the way we are going to transform is use key points for sine and cosine. The formula is given. So put a box around this. This is important. And I'm going to rewrite this, because this is going to be important too. And instead of memorizing this, I'm going to have y'all put it on a note card here in a minute. So we do transformations using that formula. We are transforming each of the key points by doing this formula to X, this formula to Y, and that'll give us our new points, and then we can graph those.